Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll use implicit differentiation to solve this problem. As per the problem, find the points on x squared over 16 minus y squared over 9 equals -1 at which tangents are either vertical or horizontal. For this problem, we have to use concepts of slope of straight line because tangent is a straight line that touches a curve at a point. The slope of a vertical line is undefined. The slope of a horizontal line is 0. We will use these concepts to solve this problem. The first step is to use implicit differentiation to find dy over dx for the given equation because dy over dx represents the slope of tangent to the given equation. We have to use implicit differentiation for this equation because if we isolate y in this equation, we get plus and minus cases. So that's why we have to use implicit differentiation. Let's start by writing the given equation. We can simplify this equation by getting rid of the denominators of x squared and y squared. We should multiply each term in this equation by the lowest common denominator. The lowest common denominator for 16 and 9 is 144. So we should multiply each term in this equation by 144. In the first term, we can reduce 144 and 16. In the second term, we can reduce 144 and 9. Now we can find dy over dx for this simplified equation. We have to find the derivative of all terms in this equation with respect to x. In the first term, 9 is the coefficient of the term, so it will stay as it is. The derivative of x squared as per the power rule is 2x. We should move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent. In the second term, 16 is the coefficient, so it will stay as it is. We can find the derivative of y squared with respect to x using chain rule. The inner function is y, the outer function is exponent 2. As per chain rule, we start with the derivative of the outer function. We should move the exponent 2 to the front of the term and subtract 1 from 2 times the derivative of the inner function y. The derivative of y with respect to x is dy over dx. Negative 144 is a constant, so its derivative is equal to 0. We have to simplify this equation and isolate dy over dx. 9 times 2 is 18. 2 minus 1 is 1. X to the power 1 is just x. In the second term, 16 times 2 is 32. In the exponent, 2 minus 1 is 1 and y to the power 1 is just y. Next, we can move 18x to the right side of this equation and it will become negative 18x. Next, we should divide both sides by negative 32y. The negative signs in the numerator and the denominator cancel each other out. We can reduce the numbers 18 and 32. dy over dx is equal to 9x over 16y. This is the expression for slope of tangent to the given equation. Now we can do the analysis for vertical and horizontal tangents. Let's start with vertical tangents. As you may know, slope of a vertical line is undefined. So we should set the expression for dy over dx to undefined. The fraction 9x over 16y will be undefined if the value of its denominator is equal to 0. This is a very important concept we need to understand and memorize. So we should set the denominator expression 16y equal to 0 and solve for y to get the y coordinates of points at which the tangent is vertical. We should divide both sides by 16. 0 over 16 is equal to 0. So the y coordinate of point where the tangent is vertical is 0. In order to find the ordered pair or the point, we have to sub in y as 0 in the given equation and solve for x. Zero square is 0, 0 over 9 is 0. We can cross multiply the 16 to the right side. We should apply square root to both sides. Square root of a negative number is not a real number. Therefore, there are no real x values for y value 0 for the given equation. Therefore, there is no point at which the tangent is vertical for the given equation. Now we can do the analysis for horizontal tangent. Slope of a horizontal line is equal to 0. So we should set the expression for dy over dx equal to 0 to find points at which the tangent is horizontal. In order to solve this equation, we can cross multiply 16y to the right side of the equation. 16y times 0 is 0. We should divide both sides by 9. I get x equals 0. This is the x coordinate of the point where the tangent is horizontal. Next, we should sub in this x value in the given equation to find the corresponding y value. Zero square is 0. 0 over 16 is 0. We can cross multiply the 9 to the right side. Next, we can divide both sides by -1. Next, we can apply square root to both sides. I get y equals plus minus 3. That means there are 2 points on the given equation at which the tangent is horizontal, and the 2 points are 0, 3 and 0, -3. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to homework help. Thank you very much and have a nice day. Bye.